Welcome to day 21 of TryHackMe's Advent of Cyber. If you've made it this far from day one, shout out to you. Congratulations for making this far. And be sure to keep on going to the very end. If this is your first one or just your first couple of ones, well, great job so far. But also take some time to go over some of the previous challenges. Now, in today's challenge, we'll be exploring how to perform an indirect poison pipeline execution attack. We'll take a look at what pipelines are, what exactly is CI/CD, what is Jenkins, various things to help us understand why this sort of attack exists, and how to exploit different things within the CI/CD process in order for us to perform this indirect poison pipeline execution attack. With all that said, let's get right into the challenge. Day 21, DevSecOps, you'll be poisoned, a pipeline of insecure code. Let's go ahead and check out this story. One of the main reasons for acquiring Antarctic Crafts was for their crafty automation in gift giving, wrapping, and crafting. After securing their automation, they discovered other parts of their CI/CD environment that are used to build and extend their pipeline. An attacker can abuse these build systems to indirectly poison the previously secured pipeline. Learning objectives. Understand how a larger CI/CD environment operates, explore indirect poison pipeline execution, and how it can be used to exploit Git. Apply CI/CD exploitation knowledge to the larger CI/CD environment. Real quick, if you're not familiar with Git, it's basically a distributed version control system that is used for tracking changes in files and coordinating work among multiple contributors, and it provides an efficient branching, merging, and collaboration capabilities for software development projects. We'll go more into what exactly it does, how to use it in this challenge. First, before moving forward, let's go ahead and look at how to connect to the machine. So make sure to review the questions in here. So the first question is, do I need to start the attack box today? Yes, you need to. So I've actually gone ahead to start my attack box to the right here, which is where we'll be doing all of our fun stuff. As a matter of fact, I will actually open this in full screen just because I prefer that view better, and we'll wait for that to open. And then over here, it says, do I need to start a VM today? Yes. All right. We already have that on. So it says deploy the target VM attached to this task by pressing the green start machine button. So it's going to be right here. I already did that. After obtaining the machine's generated IP address, you can either use our attack box or your own VM connected to TryHackMe's VPN. So today I'm going to be using the attack box. We recommend using the attack box for this task. To do so, simply click on the start attack box button located at the top right of the page. Now that we have that done, let's go ahead and look at CI/CD environments. Often, developers or other end users only see a limited portion of the CI/CD pipeline. Developers interact with Git on a daily basis, so it makes sense that CI/CD is most commonly associated with Git, although it only makes up a quarter of a typical CI/CD pipeline. The diagram below visualizes the general segments of a pipeline: development, build, testing, and deployment. While these segments could be expanded and interchanged, all pipelines will follow a similar order. And here we have the first part of the pipeline, which is the CI, which is continuous integration, and then the last part is CD, which is either continuous deployment or continuous delivery. And in continuous integration, there's the development, there's the build, there's the testing, and in the continuous deployment and the continuous delivery, you have the deploy stage. And all of this has a continuous monitoring for them. In the previous task, which is the one from the previous day, we looked at a CI/CD environment that was self-contained in Git. In a more formal environment, segments of the pipeline may be separated out onto different platforms. Below is the CI/CD environment we'll be exploring in this room. You will notice that the addition of Jenkins, a build platform, and automation server. In the next section, we will explore and discuss how these components interact and contribute to the pipeline. Now, Git is basically, in this case, where our code will be stored, and Jenkins is going to be what's going to be doing continuous integration, continuous deployment, whatever the case may be. And we can see here, Jenkins uses a Jenkins agent for this process. Now, let's look at the automation platform, in this case, Jenkins. Jenkins, along with many other applications, handles a pipeline's build segment. So remember here, we have the build segment here. So development, this is what you would do. You type that out, do your coding and all that stuff in whatever IDE you want to use, and then build, in this case, is what Jenkins would do. These platforms can be remote or local. So for example, Travis CI is a remote build platform, whereas Jenkins is a local automation server. These platforms rely on runners or agents to build a project on a pre-configured VM. One advantage of some automation platforms is that they can automatically create and configure build environments on demand. This allows building and testing in different environments without manual configuration or administration. Next, let's look at how this pipeline execution attack actually works. So in the previous task, the poison pipeline execution was introduced. Be sure to check out previous task, which is the one before this challenge. So in the previous task, a poison pipeline execution was introduced, wherein an attacker has direct write access to a repository pipeline. If an attacker does not have direct write access, so maybe a main protected or branch protected repository, for example, it's possible that they have write access to other repositories that could indirectly modify the behavior of the pipeline execution, which is exactly why this is called the indirect poison pipeline execution. Now, just in case you're not familiar with what a protected branch is, whether it's a main protected branch or a branch protected repository. So basically, when you're working within your repositories, you can protect your important branches by setting something called a branch protection rule, which defines what people that are, working within this branch can delete or push or maybe even sometimes pull from this branch or to this branch, making sure that only those with the right permissions are able to perform certain right actions or even, get data from any of these branches. It's simply a way by which you can configure better and granular access control to the branches within your overall repository-free environment. If an environment is employing a development pipeline, a configuration file must be defined for the steps the build system must take. If a repository contains all the necessary source and build files and another repository contains the pipeline files, write permissions could differ between the two, resulting in an indirect poison pipeline execution vulnerability. So given that you might have two different repositories, the source is not write protected and the repository containing the pipeline is write protected. If that doesn't make any sense quite yet, we'll look at that in a bit. So moving on. In order to exploit this vulnerability, an attacker would need to identify a file or other parameter they can arbitrarily change that the pipeline file will use. Make files and other build files are usually exploitable because they're used to build the source and can run any arbitrary commands as defined in the make file. So below is an example of what this might look like in a pipeline file. So here we see stage, steps, build. Let's go over what these things mean. Basically, this is the make stage, and this basically defines a stage in the Jenkins pipeline named make. Next, we have the steps within this stage. So it basically contains the steps that will be executed within this particular make stage. Finally, we specifically have a build step here, which is going to be done within this make stage. And this build step essentially runs a make command in the shell, and then the true part just basically validates if this command ran successfully, right? Basically, it's just a Boolean expression to confirm the actual successful run of the make command. So to weaponize this vulnerability or a PPE in general, the CI/CD environment as a whole must be taken into consideration. So for example, if a build server is used to build artifacts on a pre-configuration virtual machine, an attacker could run arbitrary commands in that environment. Let's get into the practical challenge. Now, let's apply what we've learned in this task to the Antarcticraft's CI/CD pipeline. Navigate to this, and here we should see the Git platform that is used for version control and development. Let's do that. So 10.10.39.3. Right, let's open Firefox and then navigate. Let's navigate to the IP address, which is 10.10.39.3/3, and then that's running on port 3000. All right, and here we have Antarcticraft, a painless self-hosted Git service. It's easy to install, cross-platform, lightweight, and open source. Cool stuff. Let's go ahead and sign in. Click sign in. And then we'll log in with the username of guest and the password 123. Don't save that. And here we have access to different repositories. Let's go ahead and take a look at the gift wrapper pipeline repository. And in here is where we have that Jenkins file. And this time we have two stages. And first we have the prepare stage, which runs this step, and then the build stage, which runs this particular command. Let's go back into our challenge. All right. Now let's navigate into the Jenkins platform itself. That's going to be 10.10.39.3.80.80. Do that, put a new tab, 10.10.39.3, and then that's running on port 8080. Let's go ahead and do that. And then we can sign in with the admin credentials. Don't save that. And here we have the two different pipelines. All right, let's go back here. Let's see what the challenge is saying. Looking at the gift wrapper pipeline repository, you may notice a Jenkins file, and we did notice that Jenkins file. Let's go back here, and this is that Jenkins file we saw. If a repository is unprotected, an attacker can modify a pipeline file to execute commands on the build system, So for example, an attacker could control this build stage right here and modify these commands to who am I, basically trying to find out what user is currently signed in within the system. This is possible because the Jenkins file allows you to run shell commands, as you can see here in line 13. This is an example of PPE as covered by the previous task. So this is basically just going to be a poison pipeline execution. This is not the indirect one. Now, to modify the Jenkins file, let's actually go ahead and do this. I'm just going to open up a terminal here, and then we're just going to make a new directory, and we'll call that directory challenge. All right, and let's navigate into that directory using the cd command. All right, perfect. Let's go ahead and then clone this particular gift wrapper pipeline repository. So we'll run this command, which is a git clone command, copy that, and then go ahead and paste it here. All right, if we do an ls, we can see we have this repository right here, and we can navigate into it by doing a cd into that repository. And then if we do an ls here again, we can see we have that Jenkins file. Now, after we've cloned it, we can exploit the PPE, which is the poison pipeline execution, by changing line 13. Let's go ahead and look at what's inside this Jenkins file. And here we see at line 13, we have that make true command. So let's go ahead and modify that using nano. So nano Jenkins file, and then we're going to go ahead and change that shell command to whatever we want, right? And in this case, we're going to do a who am I. Imagine what else you could do here. Maybe a reverse shell. You never know. All right. For now, we're just going to do who am I. Looks like I spelled that wrong. Who am I? Great question. So Control X and then run that and then enter. All right. And then we're going to go through a series of steps to essentially make this change possible within this repository. So first thing we're going to do is a git add. So the git add command just says git add whatever it is I'm done within this repository. Basically just add this to the list of things that I'm going to do and eventually push from my local repository into the remote repository. So the period there essentially means whatever is within this folder. And then I like to do a git status just because I want to know what have I done so far, right? So a git status will essentially show me that I've modified our Jenkins file. So we know what we've done so far. If we've modified multiple files and maybe accidentally modified a file we didn't want to modify, here we'd be able to find that out. So modify Jenkins file. Next, let's go ahead and commit what we've done. So git commit tag m, which is going to specify the message. Now, the message here is just going to be checking who am I. So real quick, what a commit does is essentially creates a snapshot of what you've done in that environment, right? It basically just creates a record of something that you've done that you eventually want to push into the remote repository. So basically just a record, an audit, a snapshot of what you've done within the current repository. And if we go ahead and do that, and here we see that one file was changed, which was the Jenkins file. There were 2 insertions and 2 deletions. The final thing we want to do now is push. So once we've committed, we need to push what we have in our local repository into the remote repository, update whatever might be up there. Let's go ahead and do that. Let's do the git push command. The username is guest and the password is password123. Oh no, we got an error here. Failed to push some refs to this remote repository. Why did we get that? Remember, because it is branch protected. So somebody must have set up some rules to ensure that we're not able to push changes from this local repository into the remote repository. And you can see here, it says user permission denied for writing. So we don't have write access to that repository. So this means that we must find another way to indirectly modify pipeline. Hence the name indirect poisoned pipeline execution. Let's look at how we're going to do that. So it says here, looking at how the Jenkins file works, you may notice that it uses make. If you recall from the previous section, a make file can be used to define a set of rules to execute steps such as commands. The make file is defined in the gift repository, meaning it could have different protections than the pipeline repository. Okay, that gives us a hint of what we might be able to do. And it says here, an attacker could add malicious commands to it. So if we're able to modify a make file, we might be able to actually poison this pipeline. Okay, let's keep that in mind. After also cloning and attempting to push changes to the gift wrapper repository, we see that our commit is successful. Well, they did that. Let's actually try to do that by ourselves. So let's go back into our terminal here and go into the challenge folder. Well, we did try to clone that gift wrapper pipeline repository. Let's this time try to clone the gift wrapper pipeline repository. Remember, the second repository. Let's go ahead and do that. So let's just scroll back here, and what we'll do is we'll copy this command again, and we're gonna paste it here. But this time, let's go ahead and just remove pipeline right here. All right, and then let's clone that repository. Perfect. All right. Now, what are we going to do next? We're going to go into the new repository we just cloned, just like we did in the previous one. Nothing changes here. Let's do an ls. Now, here we see that make file that we're talking about before. Right here. If we're able to modify this make file, maybe we could actually make something shake. So let's go ahead and do a cat on that make file. So just see what's inside it. Okay, it looks like there's a build step for this particular script, which is right here. Just out of curiosity, let's see what's in that script. So if we do a cat on that script, okay, just a bunch of commands, make a directory, run a bunch of things, and they're mostly all just commented out. So it really isn't doing much here. So looks like we can go ahead and modify that make file. Let's see what we can do here. So let's do a nano make file. And here, let's completely discard whatever this script might be doing. We don't care about that. And this time, we're going to run that whoami command that we were initially trying to run within the pipeline repository. So let's go ahead and Control X that, and then we'll say yes to save it, and then write that. All right, perfect. Remember, they said that after also cloning and attempted to push the changes, their commit was successful. So hopefully a commit will be successful. So let's go ahead and do a git add. Okay. And then again, just for reference, git status. All right, we modify the make file, and then let's go ahead and do a git commit. And then this time, let's change our message. Let's just say confirming who am I. All right, perfect. A file was changed. There was one insertion and one deletion. Now, for the finale, let's do a git push, and the username is going to be guest. Password is going to be password 123. Okay, perfect. It was successful. We have successfully pushed from our local repository to the remote repository. Depending on the configuration of the build system, different actions may initiate a new build. In this example, we have access to Jenkins, so a build can be manually scheduled by pressing the green play button. Let's go in here and navigate into the Git wrapper build, to the Git wrapper pipeline, and then let's actually run this build, schedule this build. And then while that's going on, we could just go into main, and we see that our build is running right now, which is perfect. So let's wait for that to complete. Oh, that was fast. And let's go into the last build to see what has happened here. Okay, so it looks like we had some changes. Jenkins file was updated. Okay, let's see what changes were made. Update Jenkins file. Okay, all right. Now let's see what the console output was. Okay, it's like a bunch of things were happening. Starts the pipeline. There was a first stage here. More stuff happening. More stuff happening. Oh, looks like we have the confirming who am I commit that we had. The last thing that we did. And then if we scroll down, we see during that stage, it actually ran the who am I command and told us who we are, which is Jenkins. Exciting stuff. Looks like we can do way more with this. Let's go back into the challenge and see what is next for us. All right, so if successfully executed, the command we poisoned should appear in the make stage logs, and it looks like it did appear here. Perfect. Answer the questions below. So what Linux kernel version is the Jenkins node? Let's go ahead and do that. All right, let's go back into our terminal. This time, I'm actually going to move the terminal here so that I don't lose that. And then let's make this bigger, and let's go into our challenges folder, and then let's go into the gift wrapper folder. All right, so let's go ahead and do a nano again for our make file. And this time, well, we already know who we are. We know we're the Jenkins user. So let's go ahead and run this command, uname tag A, and this will give us a bunch of information about the Linux OS, including the kernel version. Back here, we're gonna go ahead and do a Control X, and this will save that, say yes, and then write that. And then let's do a git add, and then let's do a git commit here. And then let's just say check in Linux version. All right, perfect. Looks like that was done. And then let's go ahead and push that, put in our credentials, password. Perfect. Looks like that was successful. And let's go back into Firefox in our Jenkins. And once again, let's go back into main here. And let's do that build now again. Go back in here. And looks like we had our last build, which is this number 4. Let's go ahead and go into it. Looks like it's still currently going on, almost done. And it's done. Let's go ahead and look into it. And right here, we see our commit, which was the check-in Linux version commit. All right, let's go ahead and go to the console output, scroll down here again, and here we see this is Linux TryHackMe, and then we see 5.40, 1029 AWS, Ubuntu, all that stuff. Now the actual question is the Linux kernel version. All right, the kernel version seems to be this. So let's go ahead and just copy that. And I'm gonna head back in here and grab that from here. All right. Paste that. Perfect. Looks like that was correct. And the next question is what value is found from this particular file? All right, let's go ahead and do that. Go back into our terminal. This time, let's do a clear. And then again, let's do a nano on our make file. This time, we want to do a cat of that file. So cat var lib, and I think the third was Jenkins, and finally secret.key. It's come from varlib jenkins secret.key. Varlib jenkins secret.key. Okay, let's go ahead and do Control X to exit that. We're gonna say yes. And then we're gonna do enter here and then go ahead and git add, do a git commit, and let's just say check-in secrets. Check-in secrets. There we go. All right, and let's just do a git push. Put our credentials. All right, let's go back into Firefox and then run this again. Build now. All right, we have the 5th build going on now. We'll wait for that. Perfect. Looks like it was done. And let's go ahead and click into it right here. Okay, check-in secrets was done. Okay, let's go ahead and go into the console output. Scroll down. And it ran the command for us. And here, this looks like this is the secret. Very secretive. All right, let's go ahead and copy that, and paste it. Perfect. And looks like this is our final question. Completed. There we go. All right, we just learned how to indirectly poison a deployment pipeline. Now, bear in mind that this doesn't only just apply to Jenkins. Whatever sort of CI/CD platform or CI/CD tool you're using, Travis CI, GitHub Actions, or GitLab, whatever the case is, this could easily apply to that. If you're able to indirectly modify those make files and modify those things that actually build whatever stages might occur within pipeline deployment phase or the build phase, you could easily make these changes within these environments, maybe extract information, connect to an external server, whatever the case may be, and just wreak a bunch of havoc. So make sure that you properly configure your pipelines to make sure that only the right people have access to them, and this sort of possibility of using some other sort of build file or make file to perform this sort of attack. Thank you very much to TryHackMe for this opportunity and for providing very, very quality training in regards to various aspects of cybersecurity. Be sure to follow along in the rest of the videos and the rest of the walkthroughs in 2023's advent of cyber. Thanks for watching, and I'll see you in the next video. Bye-bye.